Okay. Am I live? I think I'm live. All right. We're starting up again today. So, if you're new this episode, I want you to know. I'm saying episode, like this is like Game of Thrones. Okay. I started streaming a month ago. I'm a coder, a software engineer of many years. Since I was really out of high school, learned how to code while I was middle school, high school, hackathons, building my own stuff, working on my own startups and all this jazz. I'm now at a point where I want to give and I want to crush and I want to do something great, right? And my thought is, I'm seeing all these large language models, and I'm like, I feel like I can do it better, at least when it comes to coding. Because I'm using these things. I'm using Star Coder. I'm using ChatGPT and all this, and I'm like, why is this such a big model? Like, how big is GPT-4, and it's not even that great at designing websites? Like, it really isn't. And I've been a web developer too. Like largely web developing. Web apps, back end, front end, the whole thing. And I'm thinking, like, I feel like with my knowledge, I could train a pretty good model. So here, I have a little series. I'm trying to go through my thought process on how I can get the smallest, most effective model. And I've been self-learning a lot of machine learning and all that the past, year. Not let's say a couple years. Really, just the past year. And I feel like I'm at a point where I can start building stuff. I have a little startup going where I made a little vector DB project. And now I'm like, how do I use my knowledge in the ML department, in the Webdev department, in the coding department, combine it and actually produce something valuable? So my thought is, and I have a few other videos, so I'm just trying to catch you up here. So my thought is I want to make do I have notes here? So I want to make a Webdev LLM in which the data set looks like this, where we have these prefix tokens where I'm like, this is the title of the web page. Eventually it's going to be labeling. And the way this works is you pretty much give this model what you want to build. You're like, I want a website that looks like this. Or I want, like, you just enter in the title of your website and it should figure out what the site should look like. And then it gives you essentially an HTML document that's going to look like that page. And I know that's simple. Well, it's not simple, but I know that things like that already sort of exist. But this is going to be so small you can run it on your crappy YouTube. YouTube doesn't like me so far, so I'm trying to get on the good side. Run it on your crappy 2015 MacBook. And the way my thought process of doing that is the way transformers work is it essentially looks at each word and the context window that word exists in, and it finds, using which is the attention mechanism, how these other words, I guess, are related to this word from that word's position and also from the other word's positions, if that makes sense. And then they get these numbers to align with, which are used to predictively guess the next token when they're decoding, when they're generating a sequence for you. That's when you get GPT-4 and you ask a question, it gives you a response because it's really just generating the next sequence based on what you gave it. It's constantly generating things. So when it generates your answer, for us, it's going to generate an HTML page. It's generating it based off this context of what it knows about these words you gave it. So what does it know about the words we give this? Hey, make me a website. Oh, it knows website. About photography. Okay, it knows photography. It knows how these things are related. It knows photography's position in the sentence and the significance of that versus if this sentence started with photography, right? So there's a positional dimension to this. So the reason why I'm saying this is because I think most programming languages aren't actually, they're not built with this in mind. Same thing with templating languages like HTML and CSS. So my thought is, as elite 1337 10x engineer, just kidding. But my thought process is, as the best, one might say at the highest power level in coding, second highest, but one might say that maybe we can actually augment one of these languages so that you can learn per context window shift, per iteration in this training loop for a transformer. GPT is a transformer model. We can actually learn more about these tokens, and we can get super tokens that are so useful, that actually have a semantic element to them, so that people can understand, so that the transformer can understand how to sequentially predict the next thing perfectly. Now, long story short, I know it sounds like a lot, but long story short, for now, what I want to do and what I've done so far is create a sort of a special way of capturing HTML pages and translating it to this ideal data set with this super contextualization happening. So the first thing I did, so the first thing I did, but you get it, is crawl a ton, and this is building the perfect data set. So the first thing we did is, oh, hold on. Oh, whoops. Let's see. I did not know that someone's in the chat. My bad. Let me open up the chat. Let me open up this chat on my end here for a second so I can address this. So one second. I don't want to leave anyone hanging. Hey there, I told you about the raw data to create an AI generator which can answer questions based on raw data. Raw data contains text, tables, code snippets. Here's a link to the problem statement. Yeah, so Satvik, yeah, can you join the Discord and post that in the Discord so I can help you out asynchronously? Because, yeah, so first thing we did. So we're building this perfect Webdev data set. And hopefully this data set can be enough. And by the way, in general, if you want to ask any dev questions and stuff, Discord's perfect for that. Chat's cool too, but Discord, I will definitely address it if you post in the Discord. So the perfect web dev data set. The first thing we did is I crawled not the whole internet, but I crawled. So we made a web crawler to scrape HTML pages and label them. The labels being the question, and we're making a question answering model. And we'll figure out how to better label it. For now, just using the title of the website. So this is a very important stage. For each web page, we convert it to embedded styled template. So what that is, so what happens is we get an HTML page, a normal HTML page, and we convert it. Actually, let me do like this. So we get a normal. This is the first step to creating our awesome data set. So we get the head, we get the body, and then inside these things, we get the computed styles for each of these, okay, which is everything. So I don't know if you know, but in the browser, you can get the actual computed style. So all the things that you see, you can get the CSS elements, CSS statements for that, for each tag. So we get a snapshot. We get a snapshot of the styles for the page, and we embed it in each element's style tag. And we also compress this. I'll show you the code in a sec. We compress this so it ignores default styles. Does that make sense? So then after we compress this thing, so nice. So the reason why we have to compress it is because we don't want it to be too big. So there's a reason why I'm doing this. I'm not just embedding this for no reason. So we get all the computed styles and we make this representation where we put all the computed styles, a snapshot of what the page looks like, and we put it in each element. And part of the reason why I'm doing this is because I want when we tokenize our data to put in the data set, I want there to be not much of a separation between the styles and the tags that are associated with the styles. So I want how we style the tag to have a close contextual relationship. So why we do this. I want the styles for each tag to have a close contextual relationship with each element. So when we have these opening tags, when the things are getting tokenized, and the style tag here, I want each style to have, I don't want it to be a ton of HTML and then the related CSS. The HTML might be 1,000, 2,000 tokens, right? And then the CSS might be another 2,000 tokens. I want it, when we decode this, I want it to just in a very tight manner, be able to understand the styles related to each of these tags. That makes sense. And we can also do something to actually, we might have to write our own transformer to actually get the structural nature of the graph of this tree, HTML tree, but I don't think that's actually necessary with what we're doing here. This is an experiment, right? We're experimenting. So when I am building a project, I like to experiment. I like to mess around and test different hypotheses and different information. So the reason why this is the perfect data set for training HTML and CSS is because we're tightening up that contextual window, and we're making it so that each token has so much meaning to it. Because HTML, CSS, like tokens don't have that much meaning, right? There's a lot of different things going on with the JavaScript and CSS. So we're snapshotting the page and we're embedding all the styles together. But there's a problem with that. Part of the problem is there's too many styles. And you probably already know if you've already messed with window.compute. By the way, we use window.computed style on each element, right? That's how we get that. But so part of the problem is too many styles. And these styles don't have that much of a unique, there's not that much structure to these styles. So there's not that much of a sequential structure to the styles. They're all independent, which isn't that big of a deal, but it's also too many. So there's a couple ways to address this. To address this, I want to I built, which I'll show you that code, a semantic CSS framework off of our crawled data set. So really, so we crawl these HTML pages, we embed the styles, we build, after this we generate, which I have the script and I'll run through what I did. I did this a little offline, but I'll run through how I did the script. In this script, we essentially figured out a way to crawl. Well, yeah, we crawl, but in this script, we figured out a way to take all the styles for each element and find common styles that are grouped together to a certain degree and build a big CSS file with all these common styles. And then right now I'm going to write the script to essentially convert our data set to use this framework. This is a deep cut episode too. This is me like doing the fun stuff. This is like I'm trying to push boundaries a little bit. So if you're here, you're the 10x, you're the real 10x crew. And yeah, join the Discord if you want to get deep into stuff. You want to really work on cool stuff. I'll have other streams where I do more entry level front end stuff or build APIs, or have one where we're doing basic AI, like making Word to Vec similarity searches or doing clustering. But today, also a lot of fine tuning. If you're interested in fine tuning Llama, I have, I think, 2 or 3 videos on that. I think I have 2 fine tuning Llama videos. Started like a month ago, trying to get as much content as I can. The thing is I'm a little crazy. So what that means is I just do this all the time. I'm always working on stuff. And I don't stop. And I need an excuse to do that without looking, like, to be in society. I need an excuse to do that. And this is my excuse. So welcome to my world. Okay. So the semantic CSS framework in the end looks like this. So the way it works is we actually, the reason why it's semantic is we have this token, these tokens right here. We did using top to vec, which you can look at that video. In our data set of HTML pages, we cluster them based on their topics. So let's say we have like 80 sites. We cluster these 80 sites based on common topics in them. We haven't done this on a lot of data yet. I'm going to do that offline. I just want to get the coding down here. So we're clustering these to find topics. And the cool thing, non is a topic here, top is a topic, whatever that means. But the point is, the way in which we're naming the CSS classes for these common styles are based on the topic, I guess, that this CSS style often shows up in. And we merge these topics if it shows up in many CSS or in many different contexts. So I wish I could draw this out, but really what's happening here is we're clustering like a ton of HTML pages based on their content. So we'll have maybe I can actually do a sketch bag. Good work, G. Thanks, bro. Thanks. So let's actually go to sketch bag. Yeah, if you want me to clarify anything, ask in the chat. I'll address everything in the chat. Want me to declare anything. So the way this is actually working, so to make the perfect data set, oh look, the last thing I had, I don't have to write anything. So we cluster our HTML. This is the last stream. We're gonna get into some cool stuff. I just want to go over what we already did, because soon we'll have we will have a very tiny Webdev LLM. It'll be an LM, SLM, small language model, that will compete with GPT-4. We will. Okay. So we cluster the HTML websites based on their content. We do topic modeling using top to vec, which is really using word to vec under the hood to get these learned embeddings about the words, and then it's clustering the docs. So it's using doc2vec. I know it's a lot of stuff. Look up all these things, all these concepts, or ask me about it in the chat. But this is live, by the way. Just want to be very clear. I feel like sometimes people think this is pre-recorded, but no, I'm that good. I can't curse here. Just kidding. But anyway, so we save the topics associated with the clusters mapped to the HTML sites. Okay. And then remember, we embedded all these sites with the style embeddings. And then using these style embeddings for each topic, this is really important. We're creating a CSS framework like Bootstrap automatically. And I'll show you that script in a sec, based on common CSS combinations, okay, in the data set. That's how we get this right here. I'll show you that script. I finished it a little bit offline. But I have a stream where I started working on that stuff. So these are like a ton of common class combinations in here. And what's happening is these class combinations are going to get used, which I'm about to write, to convert. I wonder if I have a good example. Yeah, so we have data set that looks like that. It's like it's all in one line. I wish I could. Is there a way for me to just whatever? But as you see, it's just a ton of stuff. Every element has a ton of styles here, which is good, but it's like too much for the transformer. I'm trying to make this as tiny and condensed as possible. So we need to convert this to our semantic CSS framework, right? And remember, these are the topics associated with each class. And oh, thank you, Code and Tech with. So like, could you also remove all the browser default stuff? Yeah. So I actually, Kevin, I already do that. So I do a diffing. So I have this control styles thing where I get all the control styles. So these are all the default browser styles, and I diff each one when we're generating it in this, where is it? In the web crawler. So in the web crawler, we have, this is all Node, by the way. We have a diffing where we actually check if this value is if these values are already the same, and if these values are already, and by the way, I'm using StreamYard right now. Hopefully this is a little bit better. So the streaming's not happening through my laptop. I usually use OBS, which like, this has been a month. I'm figuring it out, okay? But anyway, so we do the diffing. Thank you. That's a good point. So where were we? So we right now I'm going to make the script to get these embedded styles and figure out a way. We're going to have to do some sort of greedy algorithm to just try to get to the largest, pretty much condense the styles, the embedded styles, to use these classes to the highest degree that we can. And this may not work that well the first time, but that's how coding works, is you start small and then you get big and you get big, right? Ask me if you need any questions on how this works, or if you have any comments on like how to do it better. Oh yeah, we have this topic generator. It's using Top2Vec. It's just scripts in Python. It's not all Node. And we're definitely not doing the transformer stuff in Node. I just want to be very clear about that. Okay, so let's go. So here what we have is we have this rand string. Okay, so the way I was doing something last stream with the CSS, semantic CSS framework, that was so bad. I was like, it's embarrassing what I was doing. It was so bad. So for each site, we have a long list of styles, combinations, really just all the CSS classes for that page, or all the embedded styles in an array for that page. I'm super proud of this script. I did this last night. It's so bad what I was doing. You have no idea. So, but what we're doing here, so what I was doing before is I was trying to get, which I'm still getting all the combinations, but I was trying to have an algorithm to loop through each array for each array and try to find these common combinations by looping through each array. and just like doing a reduction on like whether the bool is true, on whether or not these things are mapped together. Because the reason why I'm saying this is in all these, so we get, this is what I'm saying. So imagine, so the real problem of building the CSS framework is, imagine you have a class that's like my website class or whatever, or no, my header, and you have like a cursor pointer, and then you have like a background color that's like white, and then you have like a I don't know, like a font size that's like 16 pixels. Okay, so there might be another class on this page, or these aren't going to be classes, but there might be one that's like this. I'll use an array actually, because this is the actual structure we're doing. So this might be an array like this. This might be an array like this. I need to be able to condense these together to make sure these both account for the same occurrence. So I'm trying to find these, what am I trying to say? So I'm trying to find all the combinations that are reoccurring a lot within these like, and we also break this down. This would be, I get all the combinations within this too, because this might be like 100 different things. And then I'll get this, and then I might get an array that's like this, and then I might get an array that's like all three together. You know what I mean? So I know it's like I'm talking about a lot of different concepts, but long story short, each of those embedded styles I'm turning into an array for each element, and then it might be like 100, 200 different styles in there. And I'm finding all of the combinations within that array for every single element in the data set. Hey, what's up, Jubesy? What's up? How's it going? So what we're doing is we're building this perfect data set. We're trying to make the smallest Webdev LLM we can, because GPT-4 can suck it. I sound like an 80s like bully. You can suck it. Anyway, so the way we're doing that is we're making a very small, very, very small data set that's very contextually powerful. So each token is going to be super powerful. And the way we're doing that is we're taking a snapshot of the HTML page. This is good for me to explain. We're taking a snapshot of of each web page that we web crawl. We have a web crawler here. We take a snapshot of the HTML and CSS for every element, and then we condense that we create a CSS and automatically create a CSS framework with the common combinations of styles, which we have already figured that out. We have here, we have these random strings. It's very important for me I'm going to go over this like a lot over and over again, because it's helpful for me, and it's also just good to do that when you're trying to problem solve in the abstract, right? So we're for each of these styles, we're getting this random hash, but we're also getting a topic based on, so we're clustering each HTML page in our data set based on a topic. And these are like non is a random topic, doesn't matter. But either way, that was our data set was clustered in that way. And it was also clustered. And then we have like 2 topics because we have a super small data set. But if we scrape 1 million websites, we might have like 1,000 topics or whatever. But we label for each CSS class we find within this topic. So this cluster of HTML pages, we're labeling that CSS class based on the topic. So that's where non comes from here. And I have like, top is like 1. And then if they're common amongst multiple topics, I just keep adding them together. So non-topic. So the reason why we're doing this is once we put this into, we fine tune Llama 2 or whatever if we can fine tune GPT-2 and actually do this well, that'll be great. But long story short, we're gonna ask this to generate. We're gonna get into coding in like a second, a minute, but we're gonna get coding in like very quick. But I want to make it so that our data set is very small and very impactful. What's an example topic? Like a bunch of buttons that look the same. So we're doing the topic modeling based on. So let's go here. Where is this? Clean data set. Is this have the? So yeah, we're doing the based on this metadata. So the topic modeling for each website, each cluster is based on each HTML page's a vectorized representation of each HTML page's content. So we get all the inner text. It's super basic. I need to clean that up a little, but we're just getting all the inner text, and then we're getting word embeddings using top to vec. Look up word to vec and doc to vec. Please look at it for your own education. But we're using a representation that can give us topics from word embeddings, okay? So in the end, hopefully, in the end, so we have, oh yeah, and by the way, let me go back to how I built this so through this whole pipeline, you could actually make a perfect like CSS framework. If you actually train this on like 1 million websites, right now I did like 15 websites. It sucks. But if you train this on 1 million websites, the way it works, it should actually scale, and it should give you a very condensed like semantic. It's not something like, it's not semantic based on the components. We can get into that. I do want to do that. Right now it's based on the content. So I do eventually want this to be, I want this to be like top dash button, right? I want to do that. I have ideas on how to do that. I have a whole other, that's a whole other thing. I want to keep that. I'll tell you guys, I have an algorithm to find components on web pages. I can totally show you how that works. That's another stream though. But for now, we're just going to use the content that this class shows up in. But either way, eventually we're going to be able to have a data set. Like if you train this on 1 million sites, it's already working well enough that, I mean, if someone has the means to do this, do it, you know. You could get like a powerful CSS framework that's like super generic that would actually like, it would be in comparison of like Bootstrap. If like it would be comparable as if you trained a word to vec model on like a million Wikipedia articles versus using OpenAI's embeddings. Does that make sense? Like the more websites you add to this, the more powerful this framework is. So, but the purpose of the framework, it could actually be used for a lot of things, but right now I just made it so we can train an LLM. So anyway, so let's get into some coding. So right now, what I didn't do is I didn't make a script to actually like convert, let's call this convert data set to semantic framework. You know, it's a long file. All right, so what I need to do is I need to read my data set, which, let me just double check what the data set's called. Yeah, clean data set, right? So we need to go into clean data set, and we need to loop through each HTML page, and we need to be able to use that embedded HTML, look through each style, and essentially load up our framework right here and apply the proper styles to it. Oh, you know what? We need to convert this file to a JSON. Yeah. Let's do that first. Because yeah, we can't like parse this. This isn't really like, I mean, we can parse this, but like we need to parse this, and I should have saved this as JSON. The script takes a while to run, so I'm just gonna write a script to do it. But that's fine. So let's go and I always do this run thing. There's no real point for me to do this. Let's call it main. We're in C today. We're just making our JavaScript C. Isn't that cool? So first we got to load our data set. And so let's do fs.read file sync. You gained a new follower. I want to see you do this. Awesome. Thanks, man. Yeah. If you, dude, guys, I'm not stopping this. I'm not stopping this. I've been like, ask my buddy Matt, my buddy Matt and I, he's a very good machine learning engineer. We're gonna be talking about AI, possibly AGI. I don't know. We're gonna talk about. I don't want to. He's got his own things with his business. I don't want to get on any topics he can't talk about publicly or with the business he works for, but explain more on how to train it. So, but anyway, later we're gonna at 7:30 we're gonna stream and have a little podcast. So join for that if you're interested. Anyway, so data set. So we're just parsing this data set. I think we have to load it in as UTF-8 encoding. So we're just going to load this up. And what we're going to have to do is we're going to have to essentially, oh yeah, we also have to load up. Well, we're going to have to convert our CSS file to a JSON. It's going to be a little weird, but you know, we're going to load it as a function expression. Explain more on how to train it. So how to train it, I'm probably gonna, so in the end, we're just gonna have the data set's literally just gonna look like this. It's gonna be like some prefix tokens. So like, let's just call it tiny Webdev LLM question, whatever. And we're gonna have the question. And it's probably going to have a new line character, right? And then down here, we're going to have we're going to have another token. So by the way, when you're training LLMs, this is answer. This is really how you're, when you're fine tuning LLMs, is really how you're doing it. And the answer is going to be just our super contextual, awesome data set or HTML. I already so this is our data set's gonna be a ton of these. So we're gonna have for each website, we're gonna have this, and the question is gonna be the label. It's gonna be the description of the website, and the answer is gonna be this like super. It's gonna be what we're getting right now. So right now we're building up this data set. And in this file, actually, we're going to be creating these prompts. We're going to be outputting that so that we can go into Colab later. And I'm going to have a video where once I actually get a really good data set, I'm going to go back into Colab and show you guys. So I have another, if you want to look up how to fine tune Llama 2 to do whatever you want, I have 2 videos on that, one using LoRa, one using QLoRa. Those videos are good in my opinion for it, like, because you understand, like, I'm a traditional software engineer, coder type, gonna have to charge up. But and so I've been self-teaching machine learning, and I'm trying to approach educational things from the angle of someone who just like knows how to code, right? Because that's my position. I don't have a PhD background. I don't have a math background. I'm self-taught with everything. So I'm trying to sort of show people how to learn these things in that way of thinking. So anyway, we're gonna get this is actually gonna be the final script for our data set. We actually have 4 scripts here. We have the crawler, the topic generator, the generate CSS framework, and then we have this one we're creating now. Oh no, we have clean data set. I think that happens after. Yeah, that happens after the crawler. So we have 5 scripts in our routine here. So we're going to want to load this CSS file. So, well, This part is kind of a mistake. So like, by the way, don't use read file sync if on your servers ever. So in your endpoints, never do any synchronous, unless you have to. Don't do any synchronous calls. Always operate off of asynchronous calls because the event loop in JavaScript is far more optimized for asynchronous than synchronous. This is really a cheat, but we're not on a server, so it doesn't really matter for us. Okay, so Semantic CSS framework. Yeah, we're gonna have to convert this to. I forgot if I think it's by default UTF-8. I keep like loading things up like this. So let's get our CSS framework. It's just like a raw JavaScript file, raw CSS file. I mean, and we're gonna have to load this. So I can actually split this string. So how are we gonna convert this to? We gotta just get an object that has this as a key and these options as, let me think. We can't use the dot because I think there might be a dot inside one of these values. Yeah, I think, yeah, there could be a dot in here in one of these strings. So, but this semicolon is pretty unique. So let's actually do this. This is some dataset serialization that we're doing right now. So we have to get this, and we have to get this as an object and everything in here. So you know what? You know what I'm actually going to do? I'm going to just loop through it from index 0 to index. Let me think. Actually, is that a good way to do it? Index 0 to, or I want to see if there's a super, oh no, I could just use this first. So let's just split based off of the end bracket here. Where do you self-taught all that? The internet. Same thing when I was a little kid. I was learning how to code. It was all the internet. At home, there was like because in the 90s, my parents moved to from whatever they were doing to IT, like a lot of people. So that we had some like programming books here, but everything was just me, just in my own little world. All right, so let's get our JSON object. And 1 second, I gotta charge. I don't want to forget, and then all of a sudden lose connection here. All right, I'll be back in a sec. I'll be back. I'll be back. I'm already back. Look at that. Look at that. Look at that. Yeah, if you want to learn how to code, best thing to do is just do it. Just gotta code. I used to code so much. I mean, I code more now, which is funny. But like really like it just it becomes something where it's such a creative endeavor. Like I remember I was like in high school, and it was almost every weekend I would like get pen and paper, and I would just start like thinking of something to make. I'd think like, oh, what if I made a web browser? You know, and I'd think about something interesting about web browsers. I was like, oh, like I'm like reading all these articles online. Like, what if I could like hear the article, you know, and I'd draw out how that project would be. It was like a ritual for me to sort of figure out how to create something. It was like a creative outlet. So we're going to split based off of this character. Let's make a web browser next. Yeah, you know what's cool? I actually have a recent AI web browser project I could show you guys. Oh yeah, that one's cool. I made a thing where you could right click on links and you could ask a question and it'll just do like a vector search based off. It's like a deep link search. All right, so I think this is actually good. So we're gonna split based off. Let's just call it first split. I know it's weird. Let's split this. So we're really creating an array split from that bracket, and then we're gonna say first split. We're gonna split the split based on this. So we now have these as everything after the first index. A few months doing it and loving it. What do you love most about it? That's great to hear. That's great to hear. No, what do you love most about coding so far? All right, so we're getting this. So I think we actually have this now. Let's trim it, and then let's split based on this, and then let's map these so that we can get each of these in a separate array. So we're trying to make this the key and this in an array as the value. So let's think how to do that. So we can say CSS style. Hopefully it's the style. And oh wait, we don't have to map anything. Oh no, we do, because we have to clean it up. So we have to trim each of these. Technically, some CSS values could have. I know. You're right, Kevin. I'm just betting that it's not. So what Kevin said is that we may have some of these characters in the values of the CSS. It's possible because strings are allowed in CSS. It's not likely. We're going to check and see if this works. So this isn't perfect, but I think this gives us the value. And we now have to get, so when we split this, let's get the 0. And this is going to be this. Let's trim it. And let's slice it based off 1 so we can skip this character. Yeah, background URL. Yeah, true, background URL. Luckily, there's no background URLs in here. Yeah. Well, we'll see if this works. There's ways to get around that. So this is the key. Let's do JSON object key equals value. And then in the end, let's return this JSON object. Let's see if this works. Yeah, let's see if this works first. That's a good point. So let's load a CSS and let's get this in. Still learning, start with HTML. If you're starting with HTML and CSS, I highly suggest getting very good at JavaScript, vanilla JavaScript. Don't use any frameworks for like a month at least. Like get used to creating elements, like doing document create element, things like this. So let's go get our result, or let's get our CSS framework. Let's log and see if the CSS framework works. Oh, this is another. Oh yeah, I have a project where I scrape HN. I want to see, because I'm kind of trying to. It's an experiment, so I'm trying to scrape to get the top topics. It works actually pretty well. Oh, I think it's called cleaned dataset. Yeah, we're gonna have some errors here. Okay, it said, oh yeah, can reprise of undefined reading trim. Interesting. So we split on this, and then we do this. It would be we're doing this. Oh, you know what? It probably is. Let's log the index here. There's a way to get index quickly when you're doing one of these loops. See, now we have the index. I just want to see if this was the first thing. No. It was, yeah, you're right, Kevin. Yeah. There's definitely, in this one, there's definitely something wrong with this split. Let's say if I is 358, then let's log the, oh, yeah, it's empty. Let's just say if this split, let's just ignore it. Let's ignore our problems. Let's say if this length is not equal to 2, because I think the length has to be 2 for this to work. This might break the whole thing, I'm pretty sure. Oh, nice. Nice. Yeah, it worked. Look at that. We have like a little extra. I don't know where this came from. Oh, it's because of we're not trimming something. Let's just say if value if the last index is a 0 length, so if it's that empty string, just pop that. Nice. Okay, cool. So we got it. Nice. We did it. Look at that. Okay, so now we have this object. So now what we need to do is we need to find a way to look at each of these. We need to load with our data set. We need to loop through the data set. So we're going to get the data set item of the data set. And then as we loop through this data set, I'm going to say, and this data set item has a .html key, which is the HTML key we want to use. We probably want to use Cheerio. Where am I using? I'm using Cheerio somewhere. I steal my own code. That's what I do. If you don't steal your own code, I don't know what you're doing. I don't know what you're doing. You might be crazy. That's okay. When someone's crazy, you got to be like, that's okay. So just say, oh, yeah, that's okay. You're crazy. I don't want to deal with you. All right, so we're loading a Cheerio object. What we have to do is we have to loop through each of these styles. So we have to, I think we're still doing this in this other script. So we have to recursively, we don't have to actually recursively do anything. I think I'm just, yeah, there's no recursion. We have to do this. Same thing we have to do. So we have to get every element. So we're loading this raw string. And we have to get a buffer because the minifier I'm using converts these strings to buffers for whatever reason. Okay, so we're getting the style array. We have to figure out how to condense the style array. It's a split and then it's a trim. So you know what we can do? Let's see if the brute force thing to do. So we need to condense. We need to find matches in our framework in our data set. So this big style array, we have to find all big matches. And we could just keep picking it apart. So the smart way to do this is to have an algorithm to find, like if you have a big array and you have a list of subarrays, find which combination of subarrays compresses the data the most. So we have to have some metric for the size of the data that we want in the end. Does that make sense? So like well, what's happening here is, I mean, we don't have to do that. It's hard. Well, it's not that it's hard, but it's like that sounds not really optimal to do. Because once we find a match, we're gonna have to essentially store that state somewhere and then find a match. So we need to like look through each of these and find which combinations of these will condense it the most. That sounds like a very hard. I don't think that's polynomial time right there. You know what I'm going to do? I'm not doing that. I'm going to do it a greedy way, and I'm just going to keep the first, well, I'm going to say first occurrence of a match, just keep trying to compress it. So let's have a function for compression. So let's say compress with CSS framework. Interesting name, or interesting function name. I love naming my functions. I look like a psycho when I name my functions. I'll be like, this is what it does. Arguments, too many arguments. I should have. This is a currying. This is meant to be curried. That's how poorly written this is. See what I said there? I implied that to curry your functions, you did something wrong. I don't like function currying. Like, it feels weird and dirty. Okay, so let's go through. So really we need to pass in the style array, the big array of styles that we need to compress with the framework. So we're detecting if the style can be frameworkized. So this is frameworkizing, -izing each element. So let's do this. So let's go, and this is global. How do we do this? Oh, you know what? Yeah, that's all we need to do. And we're going to set this to the CSS class. So we're going to actually, oh, you know what we can do? We can, at the end of this, we can empty out the style. How do you delete a style in Cheerio? We don't need this anymore. Cheerio, delete style or attribute. How do you delete an attribute in Cheerio? How do you do that? Is it remove attribute? Is that what it is? Yeah, it is. It's remove attribute. So we can remove the style attribute, which is the whole point. Oh, no. We don't want to do that. We only want to, let's do this later because we want to compress it. Some styles won't map to CSS classes. So we're going to have to keep the style for those. We're going to have to pop out styles from it. So we're going to have to reattach. So let me just make a note. Reattach style attribute with styles left over. Also, the way I was able to generate the framework and to get the combinations, I forgot to talk about this, is I made a little hash function to sort. It's just because the combinations of each style might be like weird, as I was talking about, I sorted these combinations just with a generic sort because it doesn't matter what the sort is. So that whenever I find these combination of styles, I could use that as in the hash, in the object and the hash map that I create, so that as we find occurrences, we just use that key. So I don't have to. So like the thing I was doing before was literally destroying the heap, like in like a second, and the thing I have now is actually pretty fast. Hash maps are incredible. All right, so we're deduping with a hash map and the other one. All right, so reattach style attribute with styles left over. If no left over, remove style attribute. I'm just going to make a note of this. Okay, so we're going to compress with the CSS framework, the styles, and then we're scaffolding here. So like I'm writing out the logic. I'm not writing out, I don't like doing a thing where I write out like, I go deep in a function. I don't like doing that too much. I like to scaffold first. Well, we kind of did it here. Oh well, whatever. All right, so let's get, so we're compressing the framework, and this is going to be a list of classes. We're going to have the list of classes and the leftover styles. And then we're going to use that. We can actually, to do even more scaffolding, we can actually do this. We can say, and all these classes are empty, so that should be fine. And we'll just, I think this should be an array when we get it back. So we'll just join this so that this array can become, so you're on the lead stream right now. So this is only for the cool people. If you're not cool, you can just look at my React video where I just like set up React. Like you're not cool, so just kidding. I didn't know it is a meme to make fun of front end, but like front end is so cool. I don't even like, it's not, I don't even consider myself, I had front end jobs, had back end jobs, I've had like full stack, probably mostly full stack jobs. And I'll tell you, front end is so like special. Front end is so special. It's like, because that's part, if it wasn't for front end, when I was learning PHP, MySQL, little old like 90s videos when I was like a kid, I probably wouldn't have had such a like love for it, because the beauty around front end is you're turning your idea to reality and you get to see it. It's beautiful. It's a very beautiful thing. In coding, we get to do that in such a small loop. It's such a small cycle. It's a powerful thing. It's like, what other engineering field can you turn your idea into reality that quickly? You know, the back end is what is the business logic. It creates it's the central nervous system. It's what gives you the power behind what you do. But the front end makes it real. If you want to really be good at like a freelance person, be good at front end too. You'll make your clients happy. They'll get a dopamine hit. And then you make it functional because you actually know how databases work and how to set up APIs. You know how sessions work. You know how few backends or full stack people, backends obviously know this. You know how few full stack engineers actually understand cookies and sessions specifically. A lot of these boot camps, they miss that. And then I talked to an engineer and we're talking about, and then I'm like, oh, you think sessions are magic? You know, it's a little pet peeve. Okay, so let's go and figure out how to compress. So we have this HTML site with a ton of raw style tags. We want to convert it to our CSS framework or style attributes. Okay, so let's do it. Let's do something greedy. Let's find the first match. First match compress. And let's do a while loop. Let's do a while loop. Maybe we don't need a while loop. Let me think. How should this work logically? So our CSS framework, there's no duplicates in our framework, so that's cool. If we find the first thing that matches, we need to just keep looping through until we find the second thing that matches, right? I mean, I don't think there's anything. I think we just have one straight loop, right? I think that's it. I think so. So we have a style array. A style array is one large read. Yeah, optimization is underrated. Caching, load balance, etc. The foundation of big systems, especially in enterprise level companies. Yeah, 100%. Like, oh yeah, Reed, by the way, at 7, Matt and I are gonna have a big AI podcast. We're gonna be talking about Matt and I last night. We didn't do it yesterday, but last night we just kept talking about, because I was like, we were both doing our own thing and didn't have time. But last night we were just like texting about so much based future of AI stuff, and I don't want to get into too much that like I don't want like we're gonna get, because I don't care, because I'm a free man. Like I set up my life so I don't have a boss, but like I set up my life in a way where I don't have to say, I can say whatever I want. It doesn't really matter. But like we might be saying some stuff that companies won't like. But all right, so so we want to go. We need to loop through the CSS framework. So let's get we're actually going to loop through the object values. So the object values gives you an array of values for each. So this is a CSS style or CSS class. And the CSS class is what we have here. And we have each of these items. So this is a generated framework that I wrote with this script right here, where I essentially, there's a lot happening here, but the long story short, I have this, I guess, algorithm where I find the combinations of, I get a ton of this in full embedded CS styled element, styled HTML. For each style, I find common CSS classes. This is a snapshot of an HTML page. And I do this for a ton of websites. So I find all these common combinations of CSS declarations, and then I generate a CSS framework. And it's actually pretty cool. I have a little hash map. This is just the hash function is literally just sorting it. But it sorts it so that if these things are mixed up, like you have a cursor below a font size or whatever, it's finding these common combinations, making sure that I can have an occurrence map to find common occurrences. And this is the hash map, I guess. It's not a real hash map. None of this stuff is. And then, and the reason why it's semantic is because we use the topics we used from our topic generator, where we learned about, that was last stream on this, where we learned about top to vec. Okay, so let's go back to this. Just want to, I keep like explaining it because I keep trying to, because it's important to know how to explain what you're doing. Okay, so in the CSS class, we actually do want, so let's make we can say CSS class. We can do a reduce that essentially checks. So reduce gives you A and B, starts with both of them. And we can say if, I already know, because I did this like a couple streams ago, but we're gonna have to check if this is a Boolean. Because this is a reduction where we're just reducing this to a Boolean. So this is going to be a true or false if it's a match in the style array. So, and I don't know if you know, but JavaScript reduce function, it starts with the first two things. And then eventually A will become the reduction. So if you think about map reduces, you're constantly iterating through your whatever you mapped. So whatever was the transformation function, you have a cursor constantly iterating through it and returning the result of that iterator. And then you're using that as the input. That's the reduction. A reduction is, so the map, so whenever you're map reduce, it's a very important package, but it's also just a very popular way of transforming things. You'll see me do this a lot. Like when you're doing data stuff, you're always doing maps and reductions and filters and things like that. But you're mapping, you're transforming your list to something else with a transformation function. And the reduction is almost like it's like a window that's looking over your transformation to condense it into some sort of value. Here we could have did a basic loop here. We're trying to be magical, but here we're just trying to figure out if this is a match. So we're just trying to figure out if each element in here is in this list matches with a greater list. That's it. We're just trying to, it's not that complicated. But so if this is a Boolean, that means that we already we need to pass if just if B return A, and if B is in, so we need to have something to check if this has the index of this is greater than -1. So we're just checking if this value is inside our greater array. So we're just really comparing CSS to see if it's in this array. That's all it is. And then here we can do, this is the first iteration. This is the first iteration. And this should be all the other ones. Because in the other ones, A is going to be a Boolean. We could have did a basic loop, but I like doing array methods because it's important to know data transformation is very important. So we're just going to see if this occurs in all of them. So this is going to say is a match. Or we're going to say if it, I don't like that. That looks weird. Well, we'll just say is match. Okay. So check if this is a match. We want to be able to, so if this is a match, so if this CSS class, if all the styles match with the style array, reduce it. So let's remove these things. So let's loop through, and these should the CSS. So well, here we'll just do a loop. So we'll just say style of, if this style is in here, then get the index of the style. If it's greater than 1, then it does exist. Oh yeah, if it doesn't exist, the index is -1 in JavaScript. By the way, when you try to find indexes in lists, and this will treat a string like a list too, which is funny. Dynamic programming, right? It's like what is a type? I want to shake Brendan Ike, the creator of JavaScript, and be like, what do you think an object is? I want to know from you, what is a type? It's like you're so confusing, bro. So we want to splice it at this index, (1). I think that's my bad. Hold on. Let me test this out. I forgot if that's passed by reference or not. So let's test this out. I'm just trying to see how to remove an array. Let's say index 1, (1). Nice. Okay, cool. By the way, the splice, it gets the index here. And then it says it carries, it says for the following indexes after it, remove. So we're saying remove one thing at this index, right? I forgot, we're looping through the splice. This is gonna mess up. Is this gonna mess up? Because we have a reference here. I don't know if every loop it's gonna keep this reference. I think it's fine. Because we're getting, it wouldn't be fine if we got the indexes out here, but we're re-fetching the index. I think it's fine. Anyway, so this is just removing the class from the style array. And then we want to, so we want to actually have a classes to add list, which we're going to add these classes to our data set. Oh, I'm so happy if this works well. I'll be so happy. I've been like trying to figure out how to condense these data sets so much. And I think this is a really good way. And we're going to pass this to a transformer library. Not now, but we'll do it maybe tomorrow. I don't know. I really just want to sprint on this because this is my favorite project I'm working on right now. Because I think this is important. The more developers just use their knowledge to build really powerful data sets with an understanding of how transformers work. So I know a lot about web development. So I'm going to apply my knowledge to try to actually build a transformer that's going to be super beneficial to me, right? And we're just going to slowly eat away at it. It's not going to be great at first, but it's eventually we can make it good. And we can use a lot of these lessons to augment these powerful language models that we already have. So it's like I don't have to build Llama from scratch, but I could use some of their methodologies to augment with my knowledge, because Llama isn't made with my super 10x web dev knowledge, right? It's made with generic knowledge. Like they don't. I'm not saying they don't have web developers that help them figure things out. It's just it's not supposed to. It's generalizing over. The data set isn't supposed to be like this. It's supposed to be fairly generic and uniform. Like you don't want to give it a ton of raw, like data for novels and then have this like super augmented data set for HTML, right? Does that make sense? You don't want your map, your transform function to be like not uniform when you're training these generic LLMs. I haven't done it on the behind the scenes, but logically I'd think like that. So it's like, that's why it's important to learn how to fine tune. Like look at my video on fine tuning. I think I approach it in a way that would help a lot of people that don't have the ML background, because the way I'm approaching it is like, okay, I have a task I need to get done, which is this. How would I approach that from an engineering standpoint? It's like, well, the way I would approach it is essentially do it the most efficient way. Efficiency. I hate GPT-4. It's inefficient. I don't hate it. I'm just playing. Actually, I enjoy it. Okay, so we want to push to, once we get the CSS class, we can now push. Oh, I just realized we're doing object values. Let's not actually do that. Let's get the key. So we can, and then let's get the CSS class name, because the array the object we're looping is the CSS key pointed to an object of values, or an array of values. Object, it's whatever. Okay, so the CSS class is going to equal this. So this is like the actual like array of styles here. So the class name, so let's actually push the class name and the classes to add in the end. And we're updating the style array here. So you know what we can do? We can return both of these. We're done. We can return, what do I do? I get the list of classes and the leftover styles. So I have the list of classes. Just make this the same variable. And then I have the style array. Let's see if this works. And let's get the leftover styles length, because I want to see, I don't want to log all of it. It'll be too much, but I want to get the length. And I actually want to get the tag name. Is it dot tag name? Because Cheerio is a little different than actual JavaScript. So let's go and, console. Okay, so we can do this part that I got right here. I think YouTube is deleting some of my comments in the chat. They probably are. Dude, YouTube is not a fan of me. I can tell, because some videos when I'm like super like PC, they'll like it and like put it in the feed. Some when I'm not, they won't. And they'll get good engagement for what they do. I will say my turnover rate for subscribers is like super big. It's actually crazy. Like it like blew my mind. Remember I mentioned some words, I think they get shadow deleted, like they don't appear to you, but they do for me. Can you say in the Discord which ones they're deleting? I'm like, I'd want to hear what you have to say, and also I want to know what they're deleting. Okay, so let's actually, we're not gonna finish this chit chat on Discord. Yeah, let's just keep, we can use the Discord as the chat, honestly. That's probably the better way to do it. So let's convert this. Okay, that doesn't look right. So it's just, so it's a ton of empty, hold on a sec. This might be wrong. Let's see if this is a match. I want to see if, see, we have the, this is what it looks like in the end. And then we have each of these. I mean, it kind of makes sense because it does kind of make sense why this would happen. But let me think. Like the message, for example, I'll post, post in the Discord. Okay, so let me see. This didn't work first try. Oh, it worked for one of them. Oh no, it didn't work for one. It's weird that it would never be work. That none of these classes would match because a lot of these are kind of generic. By the way, this CSS framework I use is super small compared to what it should be. It probably should be a few megabytes. By the way, on inference, the reason why this is going to work is because, it's supposed to be B. Let's see if that. Okay. All right, cool. Let's get rid of that log. Nice. Oh, shit. It's working. What? That's actually working really well. So these are all the classes it found. And then these are the leftover styles. Wow. Oh, shit. It's like, by the way, I'm using StreamYard today. So can you guys let me know if this is more smooth than another stream? Wow, this is actually working. Dude, I'm so happy this is working. Because like I've been like ideating this for a bit. All right, so let's reattach the element style. It's more smooth. Nice. I'm using StreamYard and I just have it set up like in the, it's smooth. Nice. Because I've been running OBS on the computer, which is slow. So I'm just gonna use StreamYard from now on. All right, so reattach style attribute. So we need to, this is how we clean it up. This is all we need to do. So we get the style, and we pass in the leftover styles, and we just join it based on this. We'll use a space, and then we can, and that's it. Oh yeah, if there's no, so we can say if, so this needs to be an if statement. So we're going to say if the leftover styles length, which is unlikely, is 0. So if we removed everything from it, then let's go and, well, we don't want to do that if it's 0. We want to do this. Bro, doing a really good job discover YouTube channel a few days ago. I can say you probably make my lazy ass practice. Thanks, man. I appreciate it. There's many more streams. I'm not done. I'm not done. I'm going to be building a ton of stuff. I also have a Rumble now just in case because I feel like I'm getting into some risque territory. And I feel like I can tell this is probably just better to. I'm doing both though. I'm always going to go. I'm just going to keep going YouTube until I get like flagged or something. But okay, and eventually we will have the indie dev LLM that you can run on your CPU. Okay, so we don't want to remove, we want to remove style. Okay, so in the end, after this, let's get the CSS. Rumble is a yeah, you see this StreamYard, but Rumble is just an alternative to YouTube. So let's render HTML or get full HTML from Cheerio. We're using Cheerio, which is a way to So in Cheerio, you can essentially get raw HTML and then use it as if you're using jQuery. So you can, that's weird. Wait, hold on. I just need to do this. Page.html. That's weird. So, I mean, pretty sure we could just do this. Yeah, let's just do this. So it's probably going to look bad. I should test how it looks. I'm like too afraid. I know it's going to look. Oh, you know what? To test how it looks, I need to load up an index HTML page that has the framework loaded up. How big is the framework? Oh, that's kind of small. What is that like? It's not even a megabyte. It's like 300. Wait, how much is that? I'm pretty sure it's 300 kilobytes. I think. Okay, so let's just log. Let's log this. This looks good. It didn't log anything. Oh, I didn't save the file. Also, let me get rid of this. Too many logs. I think do I have another log? Wait, what? Why would there be what line is that? That's on line 69. Oh, duh. All right, let's see. Nice. All right, how does this look? So we have a style tag here. This has an empty class. Hold on. I need to just go to. This is like so hard to read. But I just want to see a class. Oh wait, these are script tags. I forgot to remove the script tags from the data set. We got to do that in clean data set. All right, but so we have a style tag right here, and then we have our classes. Nice. So it automatically, and it added classes from different. So this class was found on this topic cluster. Top is another topic cluster. And the way it's going to tokenize this, if we put in like GPT tokenizer, it's going to be and then dash, I think, is going to be a token, and then top's going to be a token. Nice. Okay. We did it. So how big is this? So let me save this to a file. Just all of them to the same file for now. I just want to see how big this is. Like I know it condensed it by a lot, compressed it, because we're not just trying to do the semantic thing. That's just a cool idea I had. I'm really trying to compress stuff. So let's do test1.html. Wait, what? Oh, okay. All right. So this is a huge page. Oh, I need to get rid of the style tags. That's so dumb. Yeah, I need to get rid of the style tags. I thought I already did that. Whatever. To really test this out, I need to look at a comparison between the clean style tag, the one that has clean style, because it's a snapshot, so it doesn't need the script tags or the style tags, because the styles are in this. So cool. I'm gonna make a testing grounds for this, probably offline, and I'm gonna test it a bunch, and then hopefully next stream I'll just start fine-tuning a data set with this. All right. I gotta go on a call with the client, so that's it for this one. This is a fun one. This is good. Did a lot of cool stuff here. Any questions about anything before I go? This is a good one. Also, I'm glad this stream's smooth. Yeah, I'm just not going to use OBS anymore. Thanks, Kevin. Yeah. Yeah, this is thanks, Reed. Yeah, guys, yeah, at 7:30, Matt and I should be back on. We're gonna be talking fun stuff. We're gonna be hanging out, talking about AI. I'm gonna go in the chat. It says, well, I guess I really triggered you into this. No, I was working on this for a while beforehand. No, I started ideating about this like in 9 months ago. And I've been slowly learning about transformers and all this stuff. Like it's been a while. I pretty much like a year, like I just doing neural networks from scratch. And then I figured out I have to do this in order to, this is what needs to get done. It's what needs to get done. You need more engineers knowing this stuff. So Reed, is YouTube Yeah, no, I know. Yeah. That's why you did get me into Llama 2. I will say that. Yeah. So, but yeah, Reed, did you see or did your comments have links in them, or did they not have any links in them? Because that's crazy. If they're deleting things that didn't have links, I know they delete things that have links. Check the Discord and show. Okay, cool. All right. It was fun. I'll see you guys in like an hour or hour and a half. I gotta figure out how to stop the stream and broadcast.